In this video, I am going to demonstrate an Arduino experiment, which ends up a digital simple clock on DumbDisplay. The microcontroller board used is ESP32. Its internal Bluetooth is used for connecting to DumbDisplay Android app. Attached with the ESP32 board is a temperature and humidity sensor, DHT11. Other information, namely, date, time and weather information, is gathered from REST APIs on the internet. Hopefully, the above is enough to be displayed as a simple but decent clock. On the wiring side, the wiring of DHT11 to your ESP32 board is not complicated. However, do note that the ESP32 board used is ESP32 DevKit board. Therefore, yours pinout may be different. Connect pin 1 of DHT11 to 3.3 volts pin of ESP32. Connect pin 2 of DHT11 to D5 pin of ESP32. A pull-up resistor of 10K is needed, which should be connected between 3.3 volts and D5. Finally, connect pin 4 to ground pin of ESP32. On the sketch side, to use Arduino IDE for ESP32 development, you will need to install the ESP32 support. There are plenty of resources on the internet showing you how to do exactly this. Basically, go to File, Preferences, and enter the URL of expressive ESP32 JSON file in the text box labeled Additional Board Manager URLs. Then go to Tools, Boards, Board Manager, search for ESP32, and install the board found. After the installation, you should be able to select ESP32 as the target development board. Say, for ESP32 DevKit board, select ESP32 Dev module. Next, you will need to install the DHT11 library. Go to Tools, Manage Libraries. In the dialog, search for DHT11. The library to use is the one by Adafruit. Of course, you will also need the DumbDisplay Arduino library, which can be downloaded from GitHub. In case you have older version of Arduino DumbDisplay library installed, you will first need to remove it. Go to File, Preferences. Note down the sketchbook location displayed. Inside the Libraries folder of your sketchbook location, is where your installed Arduino libraries are. In File Explorer, go to that folder, and locate the DumbDisplay library folder. Select and delete it. Then, you download the updated DumbDisplay Arduino library from GitHub. Now, go back to your Arduino IDE. Go to Sketch, Include Library, Add Zip Library. In the dialog box, locate the zip file you just downloaded and select it. That is it. Now, let's briefly review the sketch. Lines 7 to 10 are several options, including endpoint to the World Time API, and endpoint to the Open Weather API. It is important to note that you will need an app ID in order to use the Open Weather API. Hence, you may want to go to Open Weather Map website and get one. If you don't want to get one at this point, you can comment out Open Weather API endpoint. Also, it is assumed that you have connected DHT11 to your ESP32 board. If not yet, please comment out DHT type. Lines 24 and 25 declare the DHT object. Notice that DHT pin is declared to be pin 5, and DHT type is DHT11. Lines 30 to 32 declare the DumbDisplay object. DD Bluetooth serial I/O is used for ESP32's internal Bluetooth. Lines 39 to 44 declare the DD layers for composition of the clock. Notice that the layer objects will be created in the setup block. 3 7-segment layers are used to display hour, minute and second, 2 digits each. 2 LED layers are used for showing the separator colons between hour, minute and second 7-segment layers. A LCD layer of 20 columns by 3 rows is used to display information, namely, date, weather, temperature, and humidity. Line 45 declares the JSON multiplexer used to gather information from two API endpoints. Again, the multiplexer object will be created in the setup block. In the setup block, line 52 starts the internal working of the DHT object. Lines 55 to 60 create the layers as described previously. Lines 62 to 77 set up the different layers to make they look a bit better. Lines 79 to 85, which is just a single call to instruct laying out the layers in the desired way, using DumbDisplay's auto pin feature. The three 7-segment layers and the separator layers are grouped, and laid out horizontally. This group and the LCD layer are laid out vertically. Lines 93 to 98 create two JSON data tunnels for the two endpoint to gather information from the Internet. Lines 100 and 101 combine the two tunnels into the JSON data multiplexer object, which unifies getting JSON data from the two endpoints. After the setup block, lines 106 to 114 declare several global variables to be used in the loop block of the sketch. The variable last update temp millis keeps track of last time temperature and humidity data from DHT11 were read. The variable last get JSON data millis keeps track of last time internet data were read from the two endpoints. The variable date, hour, minute and second keep track of the corresponding data read from world time API endpoint. The variable next millis tells the time next to increment and show hour, minute and second to the 7-segment layers. Basically, it is the time of a new second. In the loop block, lines 118 to 133 read temperature and humidity data from DHT11, and show them on the LCD layer. Notice that the variable last update temp millis is used to control that DHT11 is not read too frequently. Lines 136 to 142 detect that there is no more data in the JSON data multiplexer. In such a case, it reconnects to the two endpoints again. Note that the low frequency of connecting to the endpoints is controlled by the variable last get JSON data millis. Line 145 starts the loop to read all data in the JSON data multiplexer. Line 148 reads a piece of JSON data from the JSON data multiplexer. Basically, each piece of JSON data is a field, a name-value pair. Please refer to the DumbDisplay Arduino library README for example of JSON data pieces. Notice that the read method returns the index of the tunnel from which the JSON piece was read. If the JSON piece is the field date time, lines 151 to 175 interpret the field value, and set up data, hour, minute, second and next millis global variables accordingly. If the JSON piece is the field day of week, lines 178 to 152 interpret the field value, format to display the date previously got, together with the day of the week, then show it on the LCD layer. If the JSON piece is the field weather main, lines 193 to 196 display the field value, that is the weather condition, to the LCD layer. It loops until all the JSON data pieces in the JSON data multiplexer are read. After the loop to read JSON data, lines 204 and 205 calculate the difference between now millis and next millis, and check if now is beyond next millis. Lines 207 to 219 blink the colons on the separator LED layers. Lines 220 to 231 increment hour, minute and second by 1 second. Lines 232 to 234 show the adjusted hour, minute, and second on the 7-segment layers. Finally, line 235 set the global variable next millis to the time to show time again. It loops, and the loop block logic repeats again. This concludes the sketch. If everything set up correctly, you should be able to upload the sketch to your ESP32, and see it working. By default, the sketch names the ESP32's internal Bluetooth to ESP32. You may need to bind it with your Android phone. Assuming you have the DumbDisplay Android app installed, you should be able to see the result of your work. Have fun with this ESP32 experiment.